Okay, today in class we talked about arguments. We talked about two types of valid arguments and two types of invalid arguments. So I'm going to quickly go through those four examples that we talked about today in class. All right, our first problem, our first argument is if cows moo, then sheep baa. Cows moo, therefore sheep baa. Okay, so our conditional statement, which is our first of our premises, is P, Q. Cows moo is our P statement, so therefore our sheep baa, which is our Q statement. So our symbols are going to look like this. If P, then Q, P, therefore Q. This type of argument is called modus ponens. So whenever you see an argument that follows in this pattern, if P then Q, P therefore Q, that's called modus ponens and it's a valid argument. Another way to test a valid argument is by doing it on an Euler diagram. In the center of my circle, in the bullseye, we're going to put cows moo, which is our hypothesis of our conditional. On the board of our bullseye, we're going to put sheep baa. Okay, and that's our conclusion of our conditional statement. Now we're going to test the argument that was stated. It says cows moo. So if I think about throwing my dart on my dartboard, that means I've landed in my bullseye. So if cows moo, have sheep baaed. Yes, because it's in, if I hit the bullseye, then I've definitely hit the board, and this is valid. Here's the second one. This is another type of valid argument. If you smoke, then you smell. You don't smell, so it's going to be the negation or opposite of Q. Therefore, you don't smoke. Okay, this type of argument is called modus tollens. This is another type of valid argument. If I smoke, I smell. Okay, well, let's test the argument. Here's my dart coming at the dartboard. You don't smell. Well, have I hit the bullseye? No, because I haven't hit the board either, right? If I don't smell, then that means I'm not out here. And this is fine. This is a valid argument because I knew where my dart landed. If I didn't know where my dart had landed, then I'd be in trouble. So this is called modus tollens. Let's look at two invalid arguments. If teachers talk, then students sleep. Teachers don't talk, therefore students don't sleep. If P, then Q. Not P, therefore not Q. Okay? This one is called denying the antecedent. Okay, let's test it. Teachers talk, students sleep. Okay, so now I'm going to test this argument. It's saying teachers don't talk. So that means when I throw my dart at this dartboard, I know I'm not in the center circle. Does that mean that I'm not even on the board at all? That's the problem. I could have landed here, or I could have landed off the board altogether. All I know is that teachers don't talk. I can't assume that students aren't sleeping. So this, because I don't know where the dart would have landed, this is invalid. Last one. If you hear thunder, then you hear rain. Oh, I'm sorry, then it will rain. It's raining, therefore I must have heard thunder. If P, then Q, Q, therefore P. This argument is called affirming the consequent. Okay, here is I hear thunder. Out here is rain. Okay, so now let's test our argument. It's raining. This is one of my premises. It's raining. Okay, so I know that I'm definitely on the board. But does that automatically mean I heard thunder, which is my conclusion statement? Does that automatically mean I've heard thunder? No. I'm either here or here. It could be either place. And because I don't know, this is invalid.